So what we're going to do here is use the Gauss-Jordan process, I'll call it, to find the inverse of the matrix A equals 302, 201, 211. So what we do here is we take our matrix and we augment it. We add in that identity matrix of order 3, and then we do row reductions. And obviously, because you guys are all experts at row reductions after 1 week of doing it, I can just skip straight to the bottom here and we get exactly what we need without having to do anything else, and this is a nice 20-second video. No. Obviously we can do better than that. So what we're going to do is take this step by step, but hopefully you're able to follow it a little bit easier than some of the stuff from 8.1 that you actually have had a bit of practice. Well, remember, with Gauss-Jordan elimination, even though I didn't talk about it in this way, we kind of want to form an identity matrix, because identity matrices are nice for being able to find solutions, incidentally, in terms of augmentation anyway. But we've got that form as it is, and nothing in there really feels natural to me as like a place to swap anything out to try and get a 1 in entry 1-1. That's usually where I like to start Gauss-Jordan elimination, is getting a 1 up there. But we don't have any great candidates. We also don't have any terrible ones. So I'll just keep things as they are and make my first move reducing the first row by a factor of 1/3. So just take 1/3 R1. Then I do have a 1 in entry 1-1. Good place to start. Followed by a 0, a 2/3, unfortunately. I like to avoid fractions, but sometimes it's unavoidable. And then a 1/3 on the other side of the augmentation, a 0 and a 0. But from there, I can follow along just knocking terms out for a little while. That's always the easiest part to do once you get the flavor down. So for the next step, I'm just going to eliminate the 2 in the second row's first column. So I'm going to subtract 2 times R1 from R2. That eliminates that first cell to make it a 0. Second entry is a 0. Third one, you would have 2 times 2/3 subtracted from 1. So you'd get negative 1/3. And then you have 2/3 times negative 1 plus 0. You get negative 2/3. The 1 stays the same because you're adding 0 to it. And the 0 stays the same because you're also adding 0 to it. And then you do fundamentally the same thing in row 3. Row 3 minus 2R1, you get 0, 1, negative 1/3, negative 2/3, 0, 1. It's actually an incredibly similar row, but there are a couple of really important differences that actually make our lives really nice. Because now, with the goal in mind of trying to get to an identity matrix, I can see that I have a 0 in the first column and a 1 in the second column of row 3. Because I want to get that 1 in the second slot, I'm just going to flip 2 and 3. And that will put in the second row 0, 1, negative 1/3, negative 2/3, 0, 1. Technically speaking, whenever you're in that position, you could actually add up, but then you'd have to cancel later. It's really just not worth it. If you have something like that and you want to get a value in a specific place, it's already cleared out, just rearrange. That's the best bet. Once you're rearranged, you're actually pretty close to being done. So some would have you multiply in the negative 3 there for the third row to get 1s along the diagonal like you want. That's perfectly fine. Like I've said before, there isn't one perfect way to approach row reduction. Me personally, when I see that I have a 1/3 down there and other 2/3 later, I think to myself, let's save simplifying until I get rid of those other fractions. So I'm going to try and clear out the third column first before getting it back to being a 1. So the first thing I'm going to do is subtract from row 2, row 3, which is going to get rid of the negative 1/3 as well as the negative 2/3, and it's just going to add a negative 1 in there. Then I'm going to do the same thing in row 1 essentially. I'm going to take row 1 plus 2 row 2. That'll clear out the 2/3 up there, and it'll also clean up the 1/3 a little bit, and then leave a 2. And then I'll simplify with the negative 1/3, the negative 3, and that'll leave on the left side the identity matrix of order 3, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, and then on the right side, we'll have negative 1, 2, 0, 0, negative 1, 1, 2, negative 3, 0. And that, on the right side, is really what we care about, because all this work out of the way, that's our identity matrix. That's what we've been aiming for. And I'll leave it to you guys to check the multiplication there for this to be the appropriate inverse, but know that it does work.